For 11.1 Part 1, we're going to talk about exponential functions and their graphs. Exponential functions are something that looks like f of x equals a to the x. Exponential functions have x in the exponent. In example 1, use a calculator to evaluate the following to 3 decimal places. This is just making sure you know how to use your calculator to plug in the exponents. So 5.7 to the x when x is negative 1.8. You would type in 5.7, and then you're looking for the caret button. So I'm going to get my mouse over here so you can see what I'm pointing at. This caret button, it's right here. I just highlighted it in red on the graphing calculator. The calculator that most of you use has a button that looks like that. Some calculators have a button that says like y to the x or x to the y. That would be the exponent button. So 5.7 raised to the negative 1.8. Try that in your calculator. You should get 0.044. Round it to 3 decimal places. Part B, we want 7.89 raised to the pi. You just have to find where the pi button is on your calculator. That should be 658.037. And then when you see this with parentheses, I want you to enter it exactly as you see the parentheses. So 100 parentheses 4 raised to the square root of 3. That's really kind of making you look for stuff on your calculator. 1,103.566. Okay, now we're going to graph 2 functions, and I'm going to graph them in different colors so you can see. The first one is 3 raised to the x. So we need to plug this in. 3 raised to the negative 2 is 0.11. 3 raised to the negative 1 is 0.33. 3 to the 0 is 1. Honestly, this row, you should not have to do that in your calculator. Anything raised to the 0 power is 1. 3 to the first is 3. 3 squared is 9. So let's plot these points. Negative 2, 0.11, be like there. Negative 1, 0.33. 0, 1, 1, 3, and 2, 9, 5, 6, 7, 8, 9. Be up here somewhere. When you connect these points, this is an exponential growth curve. You'll notice that it curves upward and the y values grow very quickly once you get past that 0 mark. On the left side, we are going to approach the x-axis. Because of the thickness of our pen or pencil, it's going to look like our graph touches the x-axis, but if you were to zoom in, zoom in, zoom in, zoom in, it's actually getting like microscopically close to the x-axis, but never touching it and never crossing it. That is called an asymptote. This graph has an asymptote at the horizontal line y equals 0. It will not cross that line. Okay, I'm going to graph the next one in pink. So I graphed this one in purple. I'll graph this one in pink. 1/3 raised to the negative 2 is 9. 1/3 raised to the negative 1 is 3. You might start noticing a pattern here. Anything to the 0 is 1. 1/3 to the first is 1/3, which is 0.33. And 1/3 squared is 0.11. Negative 2, 9, that'd be somewhere up here. Negative 1, 3, 0, 1, 0.33, 0.11. This is an exponential decay graph. We're starting with, on the left, with numbers that are very, very big, and then it's like we're taking 1/3 of the value of the function every time. So it's like every single time we're dividing by 3. That's why it says 1/3, because we are dividing the value by 3 every single time. In the purple one, we are multiplying the value by 3 every time. So the next one, 9 times 3, would be 27, then 27 times 3, 81. It would keep getting bigger and bigger and bigger because you're multiplying. In 1/3 to the x, you are dividing by 3 each step of the way. So you might want to write under here, this is an example of exponential growth, and this one is an example of exponential decay. And how can you tell? The number being raised to the exponent. If the number being raised to the exponent is bigger than 1, it's growth. If the number being raised to the exponent is a fraction or a decimal between 0 and 1, it is exponential decay. Here's a quick little recap of exponential growth and exponential decay. This first one is growth, which can be seen by the fact that it's increasing. This one looks like decay. It is decreasing. A couple of interesting things. The asymptote is the x-axis, which is the equation y equals 0. The y-intercept is 0, 1. The domain is all real numbers. So you might want to write next to this that this domain means all real numbers. The range is y is greater than 0. All of the y values are larger than 0. Okay, transformations, taking this graph and moving it around. Now this graph, f of x equals 3 to the x, that's the one that we just saw. We just saw this graph. It looked like this, and that y-intercept, if I go back up there, that y-intercept was at 0, 1. So I'm just going to put that 0, 1 right there so we know. I'm actually going to sketch this graph right here. If you put a negative in the exponent, it switches whatever it is. So this is an exponential growth graph, but then that negative in the exponent switches it to decay. So it'll actually make this one look the same as 1/3 to the x. So it will start large and come down and be small with that x-intercept at 0, 1. Okay? -3 to the x, and you can use a graphing calculator for this or desmos.com if you want to. -3 to the x is very similar to 3 to the x, except it flips it over the x-axis. So 0.33, 0.11. So this is the graph of -3 to the x. I just want you to look at these 3 sketches and decide what that negative does. So the negative in the exponent flips the graph over the y-axis. See how from the purple one, it just like flips it horizontally over that y-axis. In the orange one, from the purple to the orange, it flips the graph over the x-axis. So a negative in the exponent flips over the y-axis, that's a horizontal flip, and a negative in front flips it over the x-axis, that's a vertical flip. Okay, so you might want to write yourself a little note that if you have a negative in front, this negative is a vertical flip, which you might want to write over the x-axis. A negative in the exponent is a horizontal flip over the y-axis. So we talked about what negatives do. Now let's talk about adding or subtracting a number. And instead of like putting this on the graph, I want to show you in the graphing calculator. So this first one, the blue one, is going to be the original 3 to the x that we've talked about. The red one is going to be 3 to the x and then add 2 to it. And the next one is 3 to the x. Actually, I'm not going to put that one in yet. I want you to guess afterward. So if I graph both of these, they look very, very similar. What I want you to notice is that in the blue one, it is right along the x-axis. The asymptote is the x-axis. In the red one, the asymptote has been moved here, and we've got these points. This plus 2 means up 2. That moves the entire graph up 2. And because there's a horizontal asymptote, it will move the asymptote up 2 as well. If I were to graph this one, 3 to the x minus 2, what do you think would happen? That asymptote would move down 2, and our growth graph would look like that. It would move the entire graph down 2. So you might want to jot next to that, down 2. So if you have y equals a to the x plus k moves the graph up, minus k moves the graph down. Now let's look at adding or subtracting something in the exponent, up with that exponent. We've already talked about negatives, we've talked about up or down, so what's the only thing that's left? Left or right. So again, here's that original one, 3 to the x, with this point 0, 1. If I graph, take away the plus 2, up in the exponent, I add a plus 2. Some of you might assume it's going to go right 2. Close. It actually moves left 2. So left 2, we'd have this point and this point. So this plus 2 actually moves the graph left 2, which means the minus 2 is going to move the graph right 2. We call this number h, and in the exponent, in the form, it actually says minus h. So if you see a number added or subtracted in the exponent, if it's plus h, it's going to move the graph to the left. It's backwards. If you see minus h, it's going to move the graph to the right. So the horizontal movement is backwards. Plus actually means left, minus actually means right. And this is what you're going to do on part of your assignment, is look at F, look at G, and decide how these graphs have changed. So in part A, this plus 3 is going to mean up 3 because it's not in the exponent. Not in the exponent is vertical movement. In the exponent is horizontal, and it's backwards. So plus 5 means left 5. There's two things happening in C. The negative in front is a vertical flip, so it's a flip over the x-axis. The minus 4 moves the graph right 4. In part D, the negative in the exponent is a horizontal flip, so this is a flip over the y-axis. And the minus 9 moves the graph down 9. You may want to write this little guide down. So y equals a to the x minus h plus k. I wrote that in black. And then in green, I wrote the vertical changes. So if there's a negative in front, that's a vertical flip, flips that over the x-axis. If you're adding something after all of it, that's up or down movement. So plus moves up, minus moves down. Anything in the exponent is a horizontal change. So I put that in pink, that's all horizontal. A negative in front flips it horizontally over the y-axis, and the plus or minus h is backwards. So plus actually moves to the left, minus actually moves to the right. Use that guide to help you. Notice 26, 30, 32, you just have to describe the transformation, don't graph.